Hello everybody, this is Mr. Longo, and in this video we are going to simplify radicals, but these radicals are going to be a little bit more complicated than just taking the square root or the cube root of a number. This is going to involve variables and exponents with expressions in them, so it's really not that different, it's just a little bit more complicated, but don't worry, we'll get right through it, not a big deal. So you have to remember one of your properties of exponents is 15k plus 4 came from when we were just working with p to the 15k times p to the fourth power. Because remember, whenever you're multiplying variables with exponents, you add the exponents when they are a like base. So we can just simplify that really quick. And now remember, the index is 2 because this is a square root. So we just have to ask how many times does 2 go into 15k evenly? And it goes in there 7k times with a remainder of 1k. So 2 goes in here, so we can take out a 7k. So that's p to the 7k. And we are going to leave a p to the k on the inside. And now we need to ask ourselves, how many times does 2 go into 4? The answer to that is obviously twice, with no remainder. But now you have to make sure you put your answer back the way it's supposed to be, combining these two to p to the 7k plus 2 times the square root of p to the k. Okay? And that's it. So it's very similar to what we've done before. You just have to make sure that you split everything correctly. In number 2, we have an 81. Now we're working with a cubed root here. So as mentioned in previous videos, sometimes it's really easy to change this to a base. So the smallest we can work with here, 81 is actually 3 to the fourth power. And then we have our expression for our exponent, which means that could be x to the 8a times x squared. And of course, that's a cubed root. So now we can work with that. How many times does 3 go into 4? Once with a remainder of 1. So we can take out a 3 as long as we leave a 3 on the inside. 3 goes into 8a. A total of 2a times. So x goes in there 2a times. And since 3 times 2a is going to give you a 6a, you have 2a remaining on the inside. So that's x to the 2a. And then finally, 3 does not go into 2 at all. So that's just going to leave us with an x squared on the inside. And we would just have to wrap up our final answer by combining these x's on the inside. Our final answer is 3 x to the 2a times the cubed root of 3 x to the 2a plus 2, because those are common bases, so we just add our exponents. Okay? Next one. Now we're taking a kth root. So the kth root of 3k is simple. 3k divided by k is 3, so we can take out x cubed. 4k divided by k is 4, so we could take out y to the fourth. And 3 is not divisible by k, so we're just going to keep that as the kth root of z cubed. And we're done. That's it. Whenever you're taking like a kth root or any variable inside the index root, it's extremely simple to do. So again, 25 is 5 squared and 2 is not divisible by k. So we're just going to have the kth root of 25 inside. Now 2k divided by k is 2, so we can take out an x squared. 7k divided by k is 7, so we have y to the 7th. And we're done. There's nothing else we can do. Now this last example here has something on the outside already. That doesn't make it a lot more challenging. It just means we're going to have a step to do at the end. So you are not allowed to forget that we have something out there, but you should start by just simplifying the inside. So I'm just going to start with the inside here. And this would be the square root of 9m times, or a to the 9m times a squared, because this plus sign means that they came from the same base of a to the 9m and a squared. So then we're just going to ask ourselves, how many times does 2 go into 9m? And the answer to that would be 4m. So this is going to give us a to the 4m, but we did not go in there evenly, so we have a to the m remaining inside. And how many times does 2 go into 2? Once. So we can factor out an a to the first power, leaving us with no remainder. So this can be rewritten as a to the 4m plus 1 square root of a to the m. But that was just simplifying the radical. So what we need to do is take that guy and don't forget about the first guy. Okay? See what we did there? This is the exact same thing. But we have to remember to put him back out there. So that's a to the 4m plus 5 times a to the 4m plus 1 root a to the m. And as we have already talked about, whenever you're multiplying variables of the same base with their exponents, we just add them. So 4m plus 4m is 8m, and 5 plus 1 is 6. So this all simplifies down to a to the 8m plus 6 square root of a to the m. All right? So that's it for this video on simplifying radicals of a little bit more challenging type of flavor. But hey, we got through it just fine. This is Longo, and I'm out. See you, bye.